Welcome to The Explainer. We usually think of engineers as people who build bridges and machines, right? But what if they're now working at the atomic level, using AI to basically see the future and making the invisible visible? Well, that's what we're diving into today, the new superpowers that are completely changing what's possible in engineering.
So, to really get a handle on this, we have to start with the problem they're trying to solve. I mean, think about it. How do you analyze the stress on a tiny microscopic part inside a jet engine? Or track a chemical reaction that's over in milliseconds? How do you test something you literally can't even see? That's the core problem that this whole new generation of engineering tools is built to tackle. And the answer is in a completely modern toolkit of advanced analytical technologies. And no, we're not just talking about better wrenches or stronger concrete here. These are entirely new ways of seeing and understanding the world, giving engineers a level of insight into the things they build that was, until recently, pure science fiction. This line from our source material really gets right to the heart of it. You know, improving accuracy and efficiency might sound a little dry, but when you're doing it at a microscopic and computational level, well, that's a revolutionary leap. It's a game changer for how everything from bridges to microchips gets designed and built. So here's what we're going to dive into today. We're going to start by thinking really small with nanotechnology and really smart with AI. Then, we'll see how engineers are actually combining their tools with some amazing hybrid techniques. And finally, we'll look at how they're seeing everything as it happens with real-time monitoring and high-resolution imaging. All right, our first set of superpowers brings together two absolutely revolutionary ideas: thinking on an incredibly small scale and an incredibly smart one. Yep, we're talking about nanotechnology and artificial intelligence. First up is nanotechnology-based characterization. Now, this is the science of looking at materials all the way down at the atomic and molecular level. And we're not just talking about shrinking things down. This is about understanding and even manipulating the fundamental building blocks of matter itself. Think of it like this. A traditional engineer might work with hammers and wrenches, right? Well, an engineer using nanotechnology has a toolkit that lets them move individual atoms around like they're Lego bricks. It gives them a level of precision and control that's just mind-boggling. Now, pair that incredible precision with AI-assisted spectroscopy. So, spectroscopy is a classic method where you shine light on something to see what it's made of. The problem is, you get this absolute avalanche of data. And that's where the AI comes in. It acts like a superpowered detective, instantly finding tiny clues and patterns that a human would just never be able to spot. This really captures the new reality of it. The AI isn't just a passive tool you use. It's more like a brilliant lab partner who can sift through a mountain of data in a second and say, hey, look at this. It just makes human analysis so much faster and way, way more insightful. But here's the thing. These superpowers are rarely used all by themselves. The next big jump forward comes from combining them. These are called hybrid techniques, where engineers basically fuse different tools together to create something way more powerful than the individual parts. Our source points to two fantastic examples. It's kind of like creating a super map. On the left, SEM-EDS is like having a satellite image that also tells you what every single building is made of, brick, steel, or glass. And on the right, AFM-Raman creates this 3D topographical map that also tells you the chemical makeup of the soil everywhere. It's all about getting multiple layers of information all at once. Okay, so we can see things that are unbelievably small, and we can combine our tools for deeper insight. But what about seeing things in the fourth dimension? What about time? That's where our next superpower comes in, the ability to see things in real time. Real-time monitoring is an absolute game changer. Just imagine a bridge. Instead of someone checking it once a year, what if the bridge had its own nervous system? A whole network of sensors constantly feeding back data on stress, on vibration, on temperature, second by second. This lets engineers catch a tiny problem the very instant it starts, long before it ever becomes a catastrophic failure. This basically creates a constant watcher, a system that literally never sleeps. It is always observing, always providing that stream of data. This allows for what's called predictive maintenance, so you can fix a wind turbine blade before it fails, not after. And the result is just a massive leap in safety and reliability. And finally, we have high-resolution imaging. This is the power to see the world with a level of detail that, frankly, was pure science fiction not long ago. We're talking about the ability to spot microscopic flaws in an EV battery case before it ever leaves the factory, or to map out the billions of transistors on a computer chip with perfect clarity. So, let's pull all this together. We've got nanotechnology, AI, these hybrid methods, and real-time imaging. Each one is incredible on its own. But when you put them all together, what's the ultimate impact? What does all this progress really deliver for the field of engineering?
Well, when you boil it all down, it comes down to just two fundamental improvements that change absolutely everything.
Greater accuracy and greater efficiency. That's it. This is the ultimate goal of all these new superpowers. So let's really unpack what that means in the real world.
Okay, so greater accuracy lets engineers predict exactly how materials are going to behave. That means fewer design errors, which translates to safer cars, stronger buildings, more reliable electronics. And at the same time, greater efficiency means they can develop these better designs faster, with less waste and at a lower cost. It's about optimizing the entire process from start to finish.
And when you combine that pinpoint accuracy with that incredible efficiency, well, that's not just an improvement. That is a revolution in how we design, build, and maintain our entire world. This is the new foundation of modern engineering. Which leaves us with one last really exciting question. With superpowers that let us see the impossibly small and predict the future with stunning accuracy, what are the grand challenges that engineering is going to solve next? Thanks for joining us.